Yes, let's talk about the ICT greenhouse gas emissions and how they are exploding and what the developer community, we, the developers, designers, product owners, business owners should do about it. So, I'll briefly talk about myself and the book, and then let's talk about why the green coding is important, how the energy is consumed in modern software, a short discussion about measurements, waste and minimization, then what to do, some recommendations, final words. So, the introduction was really good. It was written by me actually, so anyhow, they told almost everything that was in this slide, except the languages that I've been coding. So let's go to the topic itself. So the book I wrote, if you master Finnish already, then the leftmost one is good for you, or if you want to learn Finnish, it's also a good book in that sense. And the language restricted, then they can select the English version. And I published a month ago a second edition of the book with AI, cryptos, IoT data, and some other stuff included in it. There was an extra chapter of 130 pages or so. I've heard that people have been said to me that it's actually readable, and I take that as a compliment. And it's good, even if you're not a developer, then I would say that up to chapter 6 or 7 it's okay. Then it goes a bit technical and then jumps right back to non-technical. But let's get to the topic. So why is this important? There are a number of different estimations of the climate impact of IT. Finland was the first country in the world to make nationwide climate and environmental strategy for the ITC sector, and in that very book, the Ministry of Transport and Communication in Finland, from various sources, estimated that we, as ICT sector, account for 4 to 10%, depending on the source, of the world's energy consumption. And then the Lancaster University from the UK made a meta-study that around 2 to 4% of the greenhouse emissions are caused by IT. And these numbers are growing, and they're growing extremely fast, and we are already beyond the airlines. If you take the average of the 2 to 4, it's 3, and if you take the UN emission gap report from 2022, it says that the global emissions are 58 gigatons. Gigaton is a number with 9 zeros, so it's billion tons in the US billion. And it means that every single year the IT sector spews out emissions around 1.6 billion tons to the atmosphere. To give a perspective, it's around the same amount of mass of all land mammals and people. So we are talking about something very, very big every single year, and every single year it's growing. I hopefully have your attention now. So let's talk where it actually goes. Every single modern software, is composed of 3 parts. There's the end user devices, the mobile phones that are glued to the hands, especially if you look at my children, they are always looking at the mobile phone, unless they are watching YouTube from television. It might be a laptop, it might be TV, it might be something else. And then there's the network, mobile or wired network, that connects the software or the web page running on the end user device to the cloud or data center, where the rest, the centralized part of the software, resides. And this is mostly true, for example, for the different kind of office software. The Microsoft Office has online components. Recently I'm still using, but I'm using so old Excel that the help function stopped working locally because there was nothing anymore in the internet. I could probably be happy with AD's Excel, because I haven't developed that much as an Excel user, but every 2 or 3 years there's new version and then the old version are not supported anymore, and then it causes me to upgrade my devices. I have the original iPad mini. There are 2 software that works, there are 3. There's the browser, it sort of works. For example, Helsingin Sanomat, the main newspaper in Finland, crashes it every single time when I try to scroll the article because it's so full of React. But the Helsingin Sanomat mobile app and Donald Duck mobile app, they both work, and that's sort of enough. And it's in a sense relief that I can't watch Netflix in that device. But I should buy a new device that would have no extra power for me, because I'm perfectly happy with iPad mini. It's not a slow device. And for more purpose that I could watch stuff on it. But I need to upgrade someday because software doesn't work anymore there. And that causes emissions. 80% of consumer grade electronics, the emissions happen when it's constructed, manufactured, and when it's shipped from China to some other place and configured. And only 20% of the emissions are caused by the energy. So if your company has a rule that you need to replace your laptop every single 3 years, stop it. Make it 5 years. My laptop is actually 5.5 years ago, half a year old now, and now it's starting to show its age that every single thing doesn't work anymore, and it's very slow because this is an Intel-based Mac, and every developer has M2 Macs that are way faster. So it means that the software is as fast as it used to be on their devices, and it's slow as hell on my device because this is slower. But I haven't developed as a person, and neither have you. We are all the Stone Age people still. So our capacity hasn't increased, but we have mobile phones with 120 Hertz displays. But you can't see, even with your peripheral vision, you can't see the flickering above 60. So it's complete waste. But let's get back to the topic. I could ramble on these industry stupidness for at least days, maybe weeks. I should try maybe someday. Anyhow, so we have the devices that are used by the end users. There are battery-powered devices, and then there are devices that are plugged in the wall. And then, if you think of your software energy consumption, then you should split the energy consumption of the device between all the software that's running on the device. And trust me that there are a lot of devices. I had to reboot I had to kill one process in my Mac to get the touch bar working, and it didn't help. But I had to scroll 2 or 3 screens down from reversed alphabetical order to get to touch bar server. So there was like 90 software, or 60, 90 software, I didn't count the lines, that started with W or U or X before T, or after T actually. So, and then probably there was a huge load of other systems that I have no clue whatsoever what they're up to. But they are there. Some of them are used by my software, some of them are used by some other software. How do I split it? The network connection, this is the sort of the easiest one. But there are different network connections that have a different electricity consumption per gigabyte transferred. And these numbers are easily available. And there is a lot of difference, there's a huge differences. But the last mile is typically the most important one. And as a software developer, you have no control whatsoever to the last mile because it's controlled completely by the user. You might change the way how your system reacts when it detects different kind of network connections. And then on the server side, or the cloud, that is a name for somebody else's computer somewhere, there are all the systems that participate in creating the experience to the user. Some of them are shared, some of them are dedicated, and you should calculate all of that together. energy consumption happens in the end-user device. There are the CPU, GPU, network connection, display, GPS, and the other devices inside that device. When the system is battery powered, like the mobile phone here or the laptop here, it's very, very power efficient, because users would be upset that it would, like every half an hour you should plug in the wall. But if the case is that it's plugged in the wall, then nobody really cares. How many of you in the audience know the consumption of your television? Yeah, usually there's one person. There's always somebody that has checked out. How many of you know the idle consumption of your television? I know it because it's a marketing trick and we decided to buy the television because of that factor, but I never figured out that what is actual consumption when we are looking at, and when you have 3 teenagers at home, the TV is open all quite the time. Not as much as when I go to my parents, because they're pensioners and it's always open for some reason. But the display is the biggest hog in the mobile devices. The network, if you compare 4G and optical fiber, there's 10,000 times difference in the energy consumption per transferred gigabyte. So if you are using 4G connection at your home and there's a fiber optic available, then switch. If you need to get an excavator on your yard, then don't switch. It never will change that impact will never come positive. But if it's already there, then use it. You will be once again saving the world. And then the optimized hardware that is designed to be run on full throttle on the server side. And then this question of how many of those devices you need, how well your system can be split into devices so that the devices can be packed full. And there's one French company that is a PaaS service provider that found out that 5% of the software causes like 90% of the energy consumption, because they are so badly written. And they contact their clients and they tell their clients that tell your vendor that fix this line in that file, because that's the problem. They can't fix it themselves because they don't have the authorization. Some clients do that, some don't, because electricity is still way too cheap that it matter. So software needs hardware to run. Hopefully this was not news to anybody, but that is the case still. The hardware causes emission during its life cycle, and it also needs electricity, and then the emissions depend on the type of the energy used, and there is no emission-free energy. The windmills doesn't sprout up from the ground, they need to be built, they need to be manufactured, and they need these emissions need to be collected to the estimation of the energy emissions of such power type. And there's a principle of the last power plant that if there's not enough clean energy available, then dirtier plants will be opened. And currently the world's energy consumption is growing faster than we can produce renewable energy sources. So it's paramount to save energy whenever you can. So let's take a look at how that can be done. If we agree that yes, that is a lofty goal, let's move forward. Measurement is not straightforward. I have been hinting it around that there's very hard to draw lines that you could maybe measure inside the device the consumption of your process, but how much of the consumption of the window manager is caused by your software? Because it needs to manage the windows, it needs to manage what is get drawn and what is not drawn, and so forth. And there is no really reliable data available at that much. For example, I'm dealing in the content management business, so I work with systems like Drupal and WordPress and the others. And the latest and the only measurement that I have on those systems is from 2010. And I can guarantee you that this system has been at least twice or thrice replaced. Every single line has been changed. So it doesn't bear any indication, but no more. What is the consumption nowadays? It's bigger, I don't know, it's smaller. I don't know, but I do care and I would like to get that nut cracked. So if you can measure, then do it. And if you can share the results, do it. But on the other hand, if you can't measure, you can always measure with the clock, because the University of Beira Interior in Portugal made a finding that the energy consumption and the running time of software has strong or very strong correlation. So the faster your system is, the less energy it uses. This might sound sort of common sense, but now it's scientifically proven, and also the usage of RAM, the memory, and the energy consumption has no correlation whatsoever. But this correlation is for all the languages, 17 or 18 that they checked. The other way is to reduce waste, and I borrowed this concept from lean manufacturing, where the waste is defined as any action that does not add value to the customer, that they have too many items in stock, they have extra steps in the production or whatnot, and then the manufacturing process, lean manufacturing, is focused on removing the waste from the process. We can use exactly the same metaphor of waste, that we have functionality in software that consumes energy without adding value to the user. It should be removed. The problem here is that how to find the waste and how to agree that this is actually waste, because there might be very conflicting KPIs in the organization, or there might be very conflicting ideas that what's valuable and what's not. But that's the fun of it at the end, to have a discussion and figure out. But there are different kind of ways. These are the ways that I've recognized for the book. They are explained deeper in the book. I don't really go that deep there. Go and download the book, it's free. I'll have a QR code at the end. But there's redundant software that this software is no longer used, so just shut it down. Using software in wrong task or user errors. Users are increasingly complex creatures that make different kind of errors, and then when you make something idiot-proof, then there's a new generation of idiots coming up and find out that it's no longer idiot-proof. The idiots are very, very intelligent people at finding issues at your software. My advice that never ask anything from the user. There's no possibilities for errors. Of course, if you can't do that you sometimes need to ask something, then they figure out the best way to remove errors. Because if the user fails, they will try again and again and again. Either they succeed or they give up. And everything before they succeed is complete waste. Wrong architecture, wrong data model, extra data, unoptimized data, very sort of technical stuff. The algorithmic inefficiency is typical answer when you ask from the developer that how to optimize the system. Is that okay? We'll need to have better algorithms. That I need to fix that what the other less intelligent people have been written there before me. So I'll go and fix there. The easiest answer is to get rid of the whole software. No consumption. Of course, that might not be always the case. Then you could deceive users. You have these dark patterns that like ending a subscription is extremely hard, and you need to have some numbers that have been provided during the first mail that you promptly deleted because it takes space, and the space consumes energy. There might be too much code that is transferred back and forth using wrong programming languages. There are efficient and then there are less efficient programming languages, but they have different ecosystems, and the ecosystems define the speed of the developer. If it would be about the efficiency, we would most probably everybody would be coding in C or Rust, and then those who have coded with C extensively know that this is not the right answer. I haven't not yet touched Rust. Probably it must be better because it's so it comes from different angles. But for example, Python is one of the worst languages. Ruby is not good either. I guess that it's actually the worst one. But Python is interesting because it's extremely poor language in performance, and it's used a lot with data and AI, where you need a lot of performance. This is mind-boggling for me, but it goes as usually, as Oracle is a good example, that if you have excellent software and mediocre marketing, you will always lose the mediocre software with excellent marketing. So that's probably the case with Python. Minimization is the third angle, and this is more of a design issue or problem, design matter, than coding. That try to find the minimal possible way of achieving something. You have a web shop, the person comes in, finds immediately what they're looking for, buys that and goes off. Transaction done. No fancy stuff around, nothing, no CEO greetings there, that hello, that welcome to our shop or whatnot. But then it might be conflicting to the KPIs of marketing that would like to keep the people involved in the site engaged. I guess that is the right word for 3 or 4 page loads. And if everything happens in a single page load, they can't meet their KPIs and they have failed, and then they are afraid of getting fired, and that's why they would like to have extra pages in the middle, because they could meet the KPIs. So again, the system might be flawed. But anyhow, the 3 rules. The less execution time spent, the less energy is consumed. The less data is transferred, the less energy is consumed. And less hardware is used, the less energy is consumed, and less emissions are caused, because the hardware is not manufactured for just the sake of manufacturing hardware, but somebody actually needs to buy it. So, what to do? When you start thinking about them, you need to think about the impact. The more popular your software is you are working on, the more impact your changes have. And the more popular your software is, the more responsibility you have. Very, very simple. If your software is used by millions or billions of people, like SQLite that is installed in trillions of devices and it has 3 people working on it, they have huge responsibility if they make the system a bit slower. But if your SQLite copycat is used by you and your mother, it doesn't really matter how much energy it uses, unless it's extremely poorly written, but then probably your system will melt the ground under them because it takes so much energy that dissipates as heat. So most probably that is not the case, or you would have found out. So if you are a software owner, then initiate it now and get people to help you. And if you are a contributor to something, then look for energy hogs and fix them. Very, very simple. Spend at least some time on it. Don't waste efforts in small-scale projects. And if you only work with such projects, then that's fine and dandy, but if you want to make impact, then you need to contribute somewhere else. Or make your software very, very popular somehow. But that's partially, at least, out of my experience. And then, last, some advice for different key people in the ecosystem. So, if you are a developer, you should take the matter seriously and take action immediately. You need to understand that how your application consumes energy and identify the best places to fix it. You need to minimize the data transmission storage needs because they are complete waste if they are not used. You need to challenge, positively, but still challenge the product owners and designers when they propose new features. Is this actually really needed? Is this proposed way the best way from the energy consumption perspective? And if you are a senior level developer, that you have a big beard and so forth, you need to provide guidance to less experienced people and help them to understand and appropriate solutions, because they might not be able to do it yet. If you are a designer, this is other key role, you need to understand both the businesses and user wishes. I guess that this is sort of straightforward to designers. And then you need to solve these potentially conflicting interests efficiently. Not so that it was 5 minutes and I'm done, not that kind of efficiency, but that kind of efficiency that it could take like 2 weeks, but actually the solution is so elegant and so minimized in energy that everybody is astounded about the beauty of it. Minimize the user chances of making mistakes. Again, don't ask anything if possible, and if you need to ask, then do it gradually in proper order, and keep in mind that computers memorize, people connect. So provide as much data that is available already for the user to validate or correct. Think about what the most minimal solution would be, and would that make sense? It doesn't always make sense, sometimes it makes. Discuss with the developers that when I'm proposing this, that what would be the energy consumption. Challenge them. They might not be interested, you might be interested, and slap them on the face, not physically, but mentally, and tell them that they need to focus, they need to provide you the numbers, they need to provide you indications that what would be better. Challenge them to think. And try to eliminate problems instead of figuring out solutions for them. If there's no problem at all, there's no solution needed. And that's way more ecological than solving something that would not need to be solved at all. And the users, we are all users. We and the drug industry, not the pharmaceutical, but the drug industry, are the only industries that talk about people, users. Everybody else talk about clients or whatnot, but let's talk about we, the users. So, identify how much you use time with applications, devices. It most probably will surprise you, and the surprise is not probably positive. It might be positive, but most probably it's not. Reduce if possible. The world is out there. Reduce watching videos anyhow. Most of the internet bandwidth is filled with videos, and videos is the worst format when comparing the information density and the bandwidth. Decrease the frequency of updating your devices. Never touch bitcoins. If you have touched, keep them. Don't ever give them to anybody. They are using the energy of Argentina right now, and it doesn't make any sense. The only two reasons that I found out that is extortion and drug dealing, and most probably FBI will be after you if you try this. I don't recommend. And then use all the small idle moments for dreaming and tolerate boredom. You will be more creative without the devices. And then the final words. This is a journey, so do not expect that all changes can be done at once. If you try to do it, you will just burn yourself out, and then you will be replaced by somebody else that doesn't care, and the world is a worse place. Worse place, not worst, worse place. We need to keep the business rolling. Only good business allows us to continue developing software, including making it more energy efficient. But you need to remember that there is no business on a dead planet. So if we let this planet die, it doesn't really help that, yes, but I have billions in my bank account. Do not set too ambitious goals or try to gobble up everything at once. And remember that this is a journey, and the most important thing in starting a journey is to take the first step. And I have very, very good news for you. By being here, listening to me, you have already taken the first step. You are already on the journey. Now your task is just to keep on walking and take the next steps. Thank you.